Hello everyone. So we are back with the design series. Today we are going to see the command pattern. So it is one of the most important patterns which is very widely used in system design questions. So let us see the command pattern in depth. So what is command design pattern? What does it say? The main objective of command pattern is that we can encapsulate the request in the form of an object. So that is the main point behind the command pattern. But why is it useful? So let us take an example and let us try to understand with an example basically. So let us say you are creating a download manager. Now, when you create a download manager, you can actually download multiple things. Let us say you can download images, you can download videos, or maybe audio files as well. Now, when you're passing the parameters, you can create a common request object which will be consisting of some URL and some details about the say about the downloading object. Let us say for image you might be consisting of size, and for video or audio you might be consisting of something different parameters. Now, if you are going to create different requests for all of them, then you have to maintain all those classes which are separate from each other, and you have to also create different functions or maybe overload those functions with those parameters. Instead of that, what command pattern says is just create a parent class which is called command for now, and that command will be implemented by the request object. Now you are having a family of requests. So the same family of requests can be passed into the same functions, and now the single function can act with the different kind of requests which are coming. So that is the main point behind using the command pattern. Now, by this, we are actually forming it as an object. So it will help you in parameterizing the client. Also, you can use the same request object to queue or log it. So that is also one of the useful points. Also, you can have the undo redo operations by using these request object. We'll be looking at this point into depth by taking an example, and we'll be writing the code. Now, this command interface that I just said, it will be consisting of an execute method. Now that execute method will actually have the operations that you want to perform. So for all the requests, you can just call the execute method and it will have their own different functionalities that you are going to implement. Let us see this with the example. So I'll just delete this. Let us create another file, say command.cpp. So we'll be taking the example of a text editor where we will try to undo or redo operations, and we will be having two main operations, which is write and erase. Let us see how we can implement it. Right. Hash include iostream using namespace std. So I'll just create a struct command virtual void. There will be an execute method. We'll make it pure virtual. Let the base class override it. Virtual void undo. There will be some undo functionality as well. Also, I would make a destructor virtual command. So you must be thinking why I took struct, why not a class? So there is no much difference between the struct and the class. It is just the visibility difference, and that's the point why I took it, because I want most of my functionality to be public, majorly all of my functionalities. So I just took struct, and I'll be just creating a separate video for like explaining what are the differences and at which point we have to choose struct and where we have to choose class. So we'll cover that in different video. So let us continue with the code. So I'll just create a text editor. Now in the text editor, I want to make a text, string text, which is going to be private. Now I want to have certain functionality, which is write, erase, and let us say get this string. So I'll make it public, void write. It will take a constant string s. Over that s, I want to add it into my current text. So what I'll do is I'll just say text plus equals to s, and let us also log it out. So cout text. Right. Now I'll be having an erase method, void erase. There will be a parameter with size, what number of characters I want to delete. So just call text dot erase, and we can pass the text size minus the n. So n length I have to remove. So from the total length, I'm just subtracting the length that I want to delete. And from there till the end point, the erase method will directly erase this string. Now cout text handle. So apart from this, I want to have a get method. So let us have a string get, and it will just return me the text. Right. With this, the text editor is completed. Now let us try to implement the commands that we want to have. So first we will be having a write command. Then we will be also having a erase command. Right. So the class write command, it implements publicly the command. Now inside this, I want to have a text editor and a string which is going to come for the writing, you can say. So text editor will be having a pointer ed, let us say, a string which will be passed when I want to write the string which I want to write. So a string s public. Let us have a constructor write command. I'll be getting a text editor inside it, text editor pointer. Let us name it e string str. Now we can use the initializer list. We'll just pass e comma str. Now we want to override the execute and undo method. So void execute override. We can just call ed of write, and we can pass the s inside it. Right. For undo, void undo. Let us also use override. Okay, is the name same over here? Yeah. So void undo. For undo, we just have to call erase s dot size. The string that we have just added, we are going to remove it. That's it. So this is the write command for us. So let us see what error it is showing. Incomplete type void is not allowed. Okay, why is it showing this? Okay, we just forgot to use the parenthesis over here. Okay, so with this, let us also implement the erase command. public command. Again, we will be having a text editor pointer, ed, in the string that I want to erase. So I'll just save it, and an int n size. Now inside the public section, I'll just override the methods and also a constructor. Erase command, it will be taking a text editor pointer e and an int n, which is the size. Using the initializer list, I'll just assign the variables n of n. Now let us implement the execute method. Inside the execute method, since I want to just erase the string, so I'll first get the string. So string, what is the current status of my string, which is ed of get. It will just get the string, which is in the text editor. And let us save the string, which I'm going to erase. So erased equals to current dot substring. And inside this, again, the complete size minus the n size, which I want to delete. So till the starting point, when till the starting of the deletion, till the end of the string, I'll just save it inside the erase string variable. Now ed of erase, and I can straight away pass n. Similarly for void undo, override, ed of write, I can now pass the erase. So just for implementing the undo functionality, I have to save the erase string over here. Now I'm completed with the commands. Let us also implement an invoker, which will actually maintain the status of the commands which are being used. So let us name it invoker class editor invoker. Inside this, I'm currently going to use a stack because for undo redo operation, we majorly use stack. With the operation which was performed the last, it will be popped out first. Stack of command. So now here you can see that the family of requests can be saved with the interface name. So it becomes easier. I have to make a pointer out of it. History. For stack, we have to add the library hash include stack. Now here we'll be having certain public methods. Say void run. There will be a function called run, which will take a command pointer c. Inside this, I just have to call the c of execute, and it will execute the functionality, whatever command we are just passing. And then history dot push c. The operation that I have just performed, I'll push it into the stack. Now, if I want to undo the operation, so void undo, I'll first check whether my history stack is empty or not. So if my history dot empty, in that case, the history dot top undo will be called. So from the history dot top, I'm going to get the command, and from that pointer, I'm going to call the undo method. And then I just have to pop out the command, right? So with this, the invoker class is also completed. Now let us see how we can make use of it. Int main, I'll create a text editor, say editor, an editor invoker inv. Now on this inv, I can say inv.run, and I'll just pass a new write command with the address of the editor, and let us take the string as hello. Right. Now inv.run, the next string I'm going to pass is write command, address of editor, comma, world. In the same sequence, I'm going to call run, and this time I'm going to pass erase command, address of editor, and let us take 6 characters, which is the world. So these are the 6 characters over here. So we'll just remove the world and exclamatory mark, and I will just print undoing. Inv dot undo. Let us have return 0 over here. Now the first thing that will happen is it will just add a hello to my editor. Then it will add a world. After that, it will erase 6 characters, which is going to be only hello. Then I'll be calling undo on my invoker. So the last command that was passed was the erase command. So it will revert it, and the last string that we'll be having will be hello world again. So let us try to compile it, see if there is any error. G++ command. Okay, we have just created it inside dot .vs. Let us go inside and then say command -o. Let us name it com. So it compiled successfully. Let us try to execute it. And we can see the first string is hello. The next time we added world, it became hello world. Then we erased the world. And once we call the invoker undo, it will again become the hello world, because the last command that was run was erase. So we just undo that command. So with this, we have seen how the command pattern is implemented and how we can make use of it in the system design questions.